Good morning, my name is Joelle George, and this is my lava lamp experiment. Alright, so we have all of our supplies, empty water bottle, some water, oil, Alka-Seltzer, and our food coloring. So we're going to start by putting some water into the water bottle. Alright, so we have our water in the water bottle. Our next step is to add the oil. Alright, so we have now added the oil to our water bottle. Our next step then is to add 8 to 10 drops of the food coloring. So we're going to use the red today. Alright, so you can see that we've added our drops of food coloring. Next we're going to add our Alka-Seltzer. My research said that 2 tablets is usually best, so we're just gonna start putting those in. So you can see the food coloring is pretty concentrated in the bottom, but the Alka-Seltzer is creating bubbles, which is helping that food coloring rise. Pretty interesting. It looks like even clumps of the Alka-Seltzer are rising to the top. Alright, starting to slow down a little bit, so we're going to now look as into why this is happening. So we're going to switch over to our PowerPoint. Okay, so the lava lamp was created by Edward Craven Walker in 1963. It said he was inspired when he was in a pub looking at a lamp like this. However, an actual lava lamp works a little bit differently than the one we have created for our experiment. Okay, so first we're going to look at how a regular lava lamp would work. First, you want to make sure to mix 2 liquids that are close in density to each other and immiscible, which means they're unable to dissolve into each other. So if you just mix something like salt and water, that wouldn't work because those just mix together. You need to pick things that won't dissolve into each other. So our lava lamp is good because oil and water do not dissolve into each other. As we could see, the water was completely at the bottom and the oil was at the top. The reason for that is that the oil and water are different densities. The water is more dense, which is why it was on the bottom. And then maybe this is why our lava lamp only works for a short time. Also because it doesn't use heat and it relies on Alka-Seltzer, but also my research showed that it's best to have liquids that are closer in density to each other. Maybe it's harder for it to maintain because, partially because those liquids are very different densities. Also in a typical lava lamp, instead of Alka-Seltzer, it uses heat to continue to move. So here we have our little graphic. So essentially what happens is the bulb is heated with electricity. There's a waxy compound at the bottom that the bulb heats up. As the waxy compound heats, the molecules spread apart, which makes it a light density. So that's why we going from that large waxy compound to like the smaller bubbles that are rising. However, the further it gets away from the heat source, it cools, which means the molecules are moving closer together, which gives it a greater density. So that's why it sinks back down and creates that continual cycle. So in our lamp, the Alka-Seltzer makes it a limiting reactant. We would have to keep adding more Alka-Seltzer to keep it going. In regular commercial lava lamps, it can be provided more continuously. As we mentioned a little bit before, the heavier liquid absorbs the heat, and as it heats up, it expands. As it expands, it becomes less dense and rises. And then when it rises, it cools, which makes it smaller and more dense, so it sinks. And then this seems to happen in slow motion because heat absorption and dissipation are slower processes, and the density changes are small. So now that we know how a commercial lava lamp works, we're going to look at how our lava lamp works. So, first of all, I noticed, as we noticed, the food coloring only colors the water and not the oil. Turns out that food coloring is water-based, so that is why it mixes better with the water. In our lava lamp, the Alka-Seltzer reacts with the water and then makes small bubbles of CO2 gas. So the bubbles attach to the blobs of the colored water, and that causes it to rise and float to the top. When the bubbles reach to the top, they pop, and causing that colored water to sink. How does Alka-Seltzer do this? There are two of the ingredients in the Alka-Seltzer, as we can see, are citric acid and sodium bicarbonate. We don't need to pay too much attention to the aspirin. That's for the pain relieving, and that's kind of a different thing. But the bicarbonate reacts with the hydrogen from the citric acid, and that is what forms our CO2, which causes our bubbles. Alka-Seltzer dissolves in water, which was part of our lava lamp. This is the equation for what is happening here. So the sodium bicarbonate, as we see on the left, the sodium bicarbonate is reacting with the citric acid and then forming our reaction here, which includes the CO2 and H2O. So it stops when the Alka-Seltzer has finished reacting. It can be restarted by adding more Alka-Seltzer. The limiting reactant is the citric acid, and the sodium bicarbonate is the excess reactant. So that is a look into how this experiment works. Thank you.